Alright, so now we've spent some time looking at the geologic timescale and how geologists learn about Earth's history. Now let's actually look at Earth's history and go through the different spans of time in the timescale. And we're going to start with the eons. In this recording we'll cover what is called the Precambrian supereon, which covers the Hadean, Archean, and Proterozoic eons. And in the following recordings we'll cover what's called the Phanerozoic, which deals with everything from the Cambrian until today. So starting with the Hadean eon, it's sort of a more informal, hypothetical eon that encompasses the time where, for the most part, Earth was a fairly hot environment where much of its material was liquid rather than solid rock. And we do actually have some solid material, specifically zircon crystals from this time, but there are no rocks from the Hadean. But we do know from these zircon crystals, which were dated using uranium radiometric dating, we know that there was liquid water present at some points within this eon, and we also do have some evidence that there may have been life on Earth even as early as this, but obviously in very, very simple forms. At around 4 billion years ago, we see the start of the Archean, which lasted another 1.5 billion years. And the start of the Archean is marked by the appearance of the earliest rocks on Earth. These rocks from the Archean are generally granites, as well as a form of rock called greenstone, which form greenstone belts. We also see in this eon the formation of the first continental crust, and thus continents, quote-unquote supercontinents with names like Valbara and Ur. However, because there was a lot less continental crust at this time than we have today, these quote-unquote supercontinents were a lot smaller than many of our continents today. We also see the appearance of the first prokaryotic cells, like bacteria, and we also see some of these bacteria developing photosynthesis. These being specifically cyanobacteria, which are still on Earth today, and things like algae. And we see these photosynthetic bacteria forming colonies called stromatolites, which also in some limited parts of the world, like in Shark Bay in Western Australia, still exist today, but were much, much more common in the fossil record. And we can see just with these two eons, we're already 40% of the way through Earth's history. Obviously, less happened in this first 40%, with much more happening later on, or at least our understanding of it is much better because it was more recent. But if you follow along at the bottom of these slides, each of these colors is scaled by the length of time of each eon, or when we get into the eras later. So the purple, for example, is the Hadean, the red is the Archean, so just keep an eye on that. The last eon of the Precambrian is the Proterozoic eon. It's divided up into the Paleoproterozoic, Mesoproterozoic, and the Neoproterozoic. And it lasted around 2 billion years, so you can see just with that and the previous two eons were already a good way, like something like 85% of the way through Earth's history. So the Paleoproterozoic, we start to see the effect of these photosynthetic bacteria adding more and more oxygen to the atmosphere. Before that, our atmosphere was, a lot of carbon dioxide and other gases, but these bacteria started introducing more and more oxygen to the atmosphere. Now, as you can see on this diagram here, the amount of oxygen was a lot lower than is in the atmosphere today, but still this had, a big effect on an atmosphere that previously didn't have oxygen. First of all, the oxygen also dissolved into our oceans and turned them from a reducing environment to an oxidizing environment, which meant that for the first time in Earth's history, rust could form. Before that, iron would not rust. The other thing that happened is, with less greenhouse gases in the atmosphere, less things like carbon dioxide, the Earth got colder, and we saw our first glaciation, which is known as the Huronian glaciation. Lastly, with all the oxygen, we got the formation of the ozone layer, which protected the Earth's surface from harmful UV rays and led to more complex forms of life evolving, specifically the eukaryotes, which are cells with a nucleus, which, the cells that make up our bodies, for example, are eukaryotes. After that, we have the Mesoproterozoic, which is referred to as the boring billion by many geologists, because relative to the other two eras in the Proterozoic, not as much happened. There are some good videos on the boring billion. PBS Eons did a good one a few years ago that I recommend watching. But in this presentation, we'll just skip right to the Neoproterozoic. And this saw the breakup of Earth's first true supercontinent, Rodinia. And the breakup of Rodinia caused a lot of volcanic activity, which led to the world's first, or not the world's first ice age, but the world's most significant ice age, known as Snowball Earth, where ice caps went almost right to the equator. Over time, Snowball Earth subsided. It may have come back and may have returned a few times, like, pulsed in and out of existence a few times, but overall the Earth warmed up from Snowball Earth. And towards the end of the Neoproterozoic, we have a period of time known as the Ediacaran. The Ediacaran is an explosion of life preceding the Cambrian, specifically known as the Avalon explosion, and we saw the evolution of fairly odd forms of life, fern-like animals that lived and fed on the seabed, that we're still learning a lot about, and some of the best fossils from the Ediacaran are found at Mistaken Point on the island of Newfoundland. So that is the Precambrian, which covers a good chunk of Earth's history time-wise. We went through the Hadean, the Archean, and the Proterozoic. And then the next recording, we'll talk about the Phanerozoic eon, or in the next series of recordings, which encompasses the Paleozoic, Mesozoic, and the Cenozoic.